Welcome back to the lab. Alright. You might see we got something hooked up to the scope here. And, that's because we do. Basically, what you're looking at is an intermediate step in some debug. Why are we doing some debug? Well, this daughter card just blew up. You might remember the flash of smoke, flame, fire. It's actually pretty sweet. Yeah, here, let's see if I can get these in focus. We've made a couple fun trophies. There's all that black. Yeah, these are a little singed. Yeah. Pretty fun. Yeah, so we made a couple trophies. We literally vaporized a couple traces off the board. And if I'm being honest, one of the gate drivers is reporting a fault, which is weird because it still appears to be driving the gates just fine. It's pretty weird. It is pretty weird. Maybe we blew up a cap somehow? I don't even know. Like, the bootstrap supply, I'm thinking, just isn't working well there. It's not within the limits, or I don't know. We're gonna dive into that. So we gotta figure out what's going on with one of our pairs of gate drivers. Obviously the one on the side that blew up traces and shot through. We need to figure that out. We need to figure out why it shot through. It could have just been thermal overload, and then things started to break down as the die melted inside the part. It could also be some other things, you know? Perhaps our gate drive timing isn't ideal, and so it's always shooting through, maybe a little more than we'd like, and we need to add a little more dead time. Maybe. Maybe it's just straight up the conduction losses are too high in these parts. Or maybe we need to tweak the gate drive because we're switching the high side FET on and it's actually pulling the gate of the low side FET around and causing it to shoot through. So maybe we need to drive the low side gate a little harder. Maybe we need to add a little more dead time. Maybe we need new FETs. And that is what we're going to try to find out today. Basically what we're going to do is we're going to power this on from a low voltage. And we're going to see what we see. UPS is booting. Battery charger's giving us that great squeal of trying to dump current back into the power supply. That's fine. Let's kick it on. Yeah, so we got the 4 channels. Yeah, so if I turn that off, you can see it flatlines. Turn that back on. There we are. Okay. I found the biggest problem. Well, that might be a little strong. I found a problem. And the problem that I found was this capacitor, this 1000 puff 50 volt cap, failed short on one of our FETs. The FET that shot through. Not exactly sure why, but it did. So probably some kind of overvoltage condition due to the arcs and sparks and flames and wonderfulness. So here's what we're gonna do. We removed all those capacitors because I'm not convinced we really need it for this low of a voltage, and because we're messing around with the gate drive. So hey, as long as we've got all the wires on, we can tweak the gate drive and kind of dial it in without that extra capacitance. More capacitance on the gate of FETs is almost never ideal, so let's just get those out of here. Right? For the super high voltage FETs, we needed to counteract some of those transient switching things, but we can slow down the switching if we need to. At any rate, we've got the 4 scope channels shown. Okay. What are we seeing? We are seeing things switching, things happening. I wonder how that shoot through is looking. So let's do a 0 point. Sorry about that. Hotkeys are a thing. I use a lot of them. Alright, we're zoomed in. Come on now. Scope. There it is. Alright, I can't stand that. I gotta zoom in. The current into the board is lower, and before I took off those 1000 puff caps, these heatsinks were notably warm. Notably warm. This is like fine. These are cool to the touch. If you are following along at home and you've got our schematic open, what you got to keep in mind is that we have different gate drive resistors. We've now removed those caps, so we've got different dead time programming resistor values. The schematic as it was released, I mean, the rough form is there, but we're making tweaks as we learn more and blow it up a bunch, you know? You can't just take something like that and copy it verbatim. There's some learning, there's some prototyping, there's some iteration that needs to happen. Don't mind that. Wrong, good. Alright, let's check out these gates. That looks way better. That looks way better. Oh my goodness, yeah, that looks excellent. It's not really coming through on the screen, but I'm gonna zoom back out to where I should be. Yep, that looks pretty sweet. Now, at risk of doing something spectacular, current monitor plugged in. Okay. We're powered off batteries. I really don't want this thing to blow up. I really hope our gate drive works. Whoa. Silence. We're pulling about 0.3 amps from the batteries. Whoa! Okay, so after our gate drive tweaks, whoa, guys. Whoa! Okay. Our efficiency increased so much. I forget what we were pulling before, but when I turn this on, we go from 0.18 to 0.33. That means we're only pulling like 100 milliamps. That's the gate drive, that's the high side, that's the low side. That stronger gate drive, getting rid of those caps. Ooh. We might be able to actually drive the inverter again. I wish I could load test it like this, but like, I don't know how to describe this other than it's audibly quieter. It's audibly quieter. We're at 50 volts on the batteries. Alright, our voltage reference isn't great. Our implementation isn't perfect. There's a lot of kinks to work out. I'm just shooting for not blowing up first. Okay? You gotta start somewhere. Sorry. We gotta turn this off. Hey. Oh, I'm excited. I'm excited. Okay. What do we gotta do? Okay, our other daughter card should be fine. We're gonna leave these gate drive test points on here for just a moment. Do need to kind of get them flatter though. So I'm gonna work on that. We gotta shift our daughter card up one slot and then get the inverter in here. I'm hoping that we have successfully achieved a higher efficiency than what we had before. Oh my goodness, this is not working. There we go. This long daughter card, man, that's gonna be the death of me. And that's not foreshadowing. Cool. Yeah, I don't really know where to put this fan, so we're just gonna pull this out. And instead, we're gonna use this super loud, obnoxious fan. Okay. Yeah, I don't even remember what we were trying to do when we left off. I know that we weren't necessarily trying to make this daughter card work. Oh yeah, we were trying to debug the voltage feedback on this daughter card. Oh my goodness, which we got to the root cause of. It's layout. High impedance nets plus nearby high DVDT events is a bad time. That's just a part of many pieces of debug related to this thing not working quite right. Of course, the other part of that story comes down to either things blowing up. That's a big sticking point for me. I don't like it when things are blowing up. And of course, the main microcontroller resetting. That's the other part of this debug. So here's what we've done. Here's what I'm hoping to see. When we power on, there's a couple blue LEDs that flash. The screen occasionally outputs gibberish. Actually, you know what? I bet we can get you a closer up on that. Yeah. Alright, so now you can see that screen a little better. Hopefully we'll be able to see that it's showing us something reasonable. Meanwhile, I'm going to get the DMM propped up where you can see it. I'm going to get this set to AC. Okay. All is well. All is well. Please, please, please don't blow up. We're booted. Oh, come on, baby. We got a couple daughter cards in there. We've got it booted. Oh man, I hope we get a win today. I hope that we can have fixed the gate drive. Oh, come on. Okay, nothing was permanently damaged. Looks like we just reset the main board daughter card. Not a huge deal. Let's try that again. Alright, not really sure what that's about. Okay, we're gonna give it one more reboot and try again. Let's try a reset. Oh, I need our tweezers. We gotta short out the 24 volt bus, get it below 1.8. So that will do a hard reset of the mainboard micro. Okay, here goes nothing. Alright, we saw the 120 volts for a little bit. Okay, before we go and give up on this whole thing, cool. Let's go for it. Okay, we're booted. Yeah. Gotta get the scope clipped in. This is probably super legit. No worries about that. Okay. Oh, look at that beautiful sine wave. We are back to exactly where we were before. A excellently functioning daughter card. Ruh-roh. The daughter cards do the power electronics dance incredibly well. The mainboard micro maybe resets a little more than it should. But we have a sine wave. I'm gonna kick that one more time, just to do a little victory lap. We have a UPS again. It indeed does not blow up. We can try to load it again. Hopefully it won't shoot through under load. Oh, look at that. There's some noise. There's some noise. Oh, that's awesome. Okay. Back to where we were. Back to where we started. Excellent. Well, I tell you what. This is not the end. Oh no, my friends. There's a lot more that we have to do. I'm really glad that we fixed this daughter card. I'm really glad that we fixed the gate drive on our battery daughter card. I'm really glad to see that giant fireball that was copper sublimating. Yeah, I'm really glad that everything survived. Man, this design is resilient. It's putting up with me making all kinds of mistakes. And sure, we've had to replace a lot of FETs and take off some caps, and blow up some more FETs, a lot of fuses. Okay, it hasn't been an easy ride, but I hope that you've been having some fun. Okay, well, I hope you learned something maybe about gate drive. If you like this video, make sure you get subscribed so you don't miss it. Just want to say thank you to those that have supported us on Patreon. Really appreciate you guys throwing $1 in the hat and helping us to do great projects like this one. Alright guys, see you in the next one. Bye.